Alright everybody, I think I'm back live. Sorry about that. I'm still having that same tech issue where my computer just randomly crashes without warning sometimes. I really wanted to basically get new hardware this year, but with the crazy prices of RAM and graphics cards, I decided to wait and instead got new mic and everything, so maybe soon. Anyway, let's get back to programming. I think, yeah, I am back live now. I'm not sure where you guys left or last saw me. Hopefully I didn't lose too much work. But yeah, basically, this is what we're gonna work on once I finish changing to get the lerping functions and everything. And we'll need to create all these points again. I'm trying to figure out how I want to number them. I guess we should just go like this. So the index would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically, this is the number of subdivisions. So to go, I'll go ahead and number it while Visual Studio is loading. Oops, it should be a 0. Another one hidden? Yeah, I thought I duplicated that one too many times. Come on now. Okay, so this, for example, is a margin with one subdivision. Which basically is this. So a margin with 0 subdivisions would just have this numbering. So we have 1, 2, 3, 4, 5, 6, 7. I think. Oops. Okay, so this would be a margin with 0 subdivisions. And I think this number depends on the number of subdivisions of the hexagon. Or the number right here. Because this is basically the number of points at the end of the hexagon, which is number of subdivisions plus 2, I think. Oh no, just plus 1, because on 0 subdivisions there's 2 points. But anyway, we'll get back to that soon. Okay, so back to the graphics. Looks like it crashed right as I was doing that part. So yeah, I was saying that if any two prototypes are equal but they're not all equal, then we'd have to do a triangle combination anyway, so I won't test that. If proto C is null, then we just lerp between proto A and proto B, and for now I will just hack and do 0.5. At some point I'll need to transform these into the combination of the 2 points. I think I might know how to. Thinking about it while everything was crashed, but I won't worry about that for now because it's not really needed until we add triangle subdivisions. Alright, this should be 0, 1. Oh, what's wrong with this? Vector 3 to float. Oh, so it wants the lerp value here before the blends. Okay, and then if B is null, then we just blend between A and C. And the only difference is we change this to 1. That would have... Like, I'm surprised I didn't ever get any problems from that, because that's a pretty big issue. Okay, so for any other reason we need to blend the 3 points. Okay, so yeah. And we can construct the blend vector this way. Alright, and so really all I need to do is use the new version of the bump height. Yeah, this is not needed. I don't know why that was in there already, because I thought I already checked. Oh, I don't check if just proto A is null. That's probably something good to make sure. I don't know if it can ever actually happen in the code, but just to be future-proof. So here we lerp between B and C, and then we change that to 1. Okay, so now we know that none of the prototypes are null, so that means we're not on an edge. Okay, so we need to figure out the third flat point for the third prototype. Okay, and then we just need to use the version that takes a triangle average. Alright, and I'll just copy this to all of them and change up the direction vectors again. Looks good, and then this is the same, and for position... Oh yeah, we just need to, again, use this new get bump size and multiply it by vector 3 up. And here we'd use vector 3, 0. Okay, so now we finally have gotten that all taken care of. Do I need this anymore? Yeah, it's not. That's used. I think that was used in our old code. Also, I don't take into account if only prototype C is not null, which I probably should. Actually, since this make new point has these checks, I think I don't need any of these things because that would already pass through. Although I guess I would need to check if they're all equal. Yeah, so I can take these out. That simplifies it a little bit. Because these checks to see if 2 are null is already taken care of right here. Let me see. Note that checks for 2 null prototypes are taken into account in the 2 lerp make new point. Although if all are null, then we don't really know what to do, so we don't ever take... I don't think we ever worry about that, so it's no big deal. Okay, so let's say if A and B were null, then it would go here, proto B equals null, and then it would try to lerp between A and C. And then here we would see that A is null right here, and so then it would just use the second. So I think that's gonna work. C null, so AB, B null, AC. I'm just checking to make sure I don't mess up the values here. And A is null, then BC. Yeah, so that is fine. And then if they're all equal, then we can just make new point. We do have to check that. Alright, okay, so back to this. I think that's all done. I don't use these other versions of triangle average right now. Actually, but I need to because that's a 2 version, yeah, 3 version. Because I just use a flat position, but I actually need to average between flat A and B. I don't do that here either. So math F, lerp, flat A, flat B. Yeah, because that's basically what this does. It lerps between them as well, so they get the same center point. It's a little, I mean, we calculate that lerp twice, but it's okay. Oh, this should be vector 3. And then here we'll use triangle average. And again, even though we're passing in this, and we could just calculate the position and then pass that in here, but it would still need to take into account the 3 different prototypes, so. Yeah, but in this get bump size, it just calculates a triangle average again. Is that the way I want to do it? Now that I think about it. Because the reason that we have to do this is because the positions are different because of the distort amount. But I think we might want to go ahead and average the distort amount so that the bump is being sampled at the same position for all 3 prototypes. Yeah, I think I might have done this logic wrong. Yeah, so we actually use the same position. That's how I had it originally. Again, I overthought things. Oops. And then, yeah, so we lerp between these 2. So vector 3 center is math F lerp flat A, flat B, and then lerp. And again, this should be vector 3. Okay, that's better, I think. Because that way it samples the bump size at the same center for every prototype, even though, and then we factor in the different distortion amounts here. Yeah, that works better. Alright, yeah, I like that. So I think we're finally done with these make new point functions. And we can actually uncomment this beast and try and figure out how to do it. Oh yeah, this make new point needs to have the blend value now, so I can just pass vector 3, 1, 0, 0. Same with this. I guess I should make sure that the code is still working. So let's go ahead and run it. After it recompiles, all those errors should disappear. I think it should. Yeah, I have nothing in here. Yeah, so it still looks fine. I don't see any issues. I guess let's load up the normal visualizer. Okay, yeah, and they're good. Okay, so I kind of want to do something similar to this for the margin. So this gives us cell index aside, and then if it should make a triangle or not. Yeah, worry about the triangles separately, but so I want to make all these points first, and then we'll form the triangles from them. And again, there's a little different handling depending on if the point is on one of these, I guess, odd rows or an even row. I guess this would actually be row 0, so this is 1. Yeah, so the even rows have the same number of points as the subdivisions in the hexagon, or the points at the edge of the hexagon, which is the number of subdivisions plus 1. Or plus 2, actually. Because at 0 subdivisions, it just looks, everything is just a triangle here, so there's 2. And we don't have to worry about sharing points with the margin triangle or the hexagon because they'll have different blend values, so we actually can't share points with them. Or terrain indexes will be different as well, so we'll just have the share points within the margin. And it will still have a smooth line there because we're going to what I'm looking for. We're going to still have the normals sample the textures that would be on over this way, so they'll still, the normals for this point and, I mean, on the hexagon and this point on the margin should be pointing in the exact same direction, which means that it'll still have smooth lighting, like there shouldn't be a seam or anything. Okay, so I don't even know if we'll use this. We need to figure out the points. We'll actually have pretty much completely different code for the triangle. I think I actually tag on the margin triangle here. It's interesting. It's anything, I don't even know if anything actually uses this make triangle. I guess it must, because some things don't create the triangle. But regardless, we will. So let's see. Private void. Or actually, well, Yeah, it'll be void. Fill margin. Let's call this the rectangle points. And we'll have the cell index, the side, and then we'll have an array of try points. Hi Goliath. Looking for someone who knows how to create websites and blockchains. I have an idea and would like an expert to help execute it. Unfortunately, I don't really have much experience with either of those subjects, so I don't know how much I could help. Sorry about that. More into like games programming here. But I hope you find somebody. Okay, so I guess, well, do I want to just return an array of points? I mean, there's no reason that this code has to create this array, really. Unless we wanted to reuse the array. I guess I will do that in case I decide to do that. Okay, Goliath. Yeah, I really don't have any experience, so yeah, I can't help you, but yeah, good luck in your search. Okay, so we'll just assume that the try points is already set to the correct size here because, yeah, if I decide to reuse this array, I won't want to be creating it myself. So this will be rect points. Oh, I don't know the size yet, actually. So int number of rect points, and this should be simpler. So really, if we have the number in this row and the number in this row, the total number is this times the number of subdivisions plus 1, because we have to take into account the end row. And then this is the number of subdivisions. Alright, so let's see. Int num points and what do I want to call this? I guess let's just call them a big and small row. Well, the small row is just a number in the big row minus 1. You too, Goliath. Thank you. Let me see. So again, it's the number of hex subdivisions plus 2. I'm trying to, should I like separate this out into another function? I guess if I ever have to do the same math twice, I probably should, in case it ever changes. Int num points at hex edge. I don't know, it's kind of, I guess it's a good idea, but I'm gonna start bloating this thing out with a bunch of methods that is kind of just self-evident. I could have to actually change the definition here, but I guess I'll try to be good. And then number of points in small row is just the number of points in the big row minus 1, and so total points is number of points in the big row times database metrics, margin. What does margin rings mean? Okay, I guess that's like one segment, one triangle ring. Actually, it looks like it does. I think one ring is referring to this whole part. So what if it's 0? What do I set it? Oh, it's set to the wrong folder again. Extra widths, margin subdivisions is 0, okay. So do I just pass that through? I don't really like the name here. I think I'll rename both these to X subdivisions and margin subdivisions. Actually, this should just be the margin rectangle subdivisions, because if we have margin triangle subdivisions, it might... Or if we ever support that, we'd need another value there. I do have that, though. So the number of points, we multiply that plus 1. Oh, actually, no, it's plus 2, because if it's 0, then we have 2 rows of the big row, and then we just have 1 of this. Plus points in small row times plus 1. Okay, so that's the total number of points. Yeah, quite a bit simpler than for hexagons. Alright, and then we pass it to fill, margin, rectangle points. Hey Chocopix, how are you doing today? It's been a while. Googly eyes at all the math, yeah. The only bad thing about working with mesh is you have to do a lot of geometry. Okay, let me see. So I guess we'll start here. Maybe we should break this up further to just do... Well, I don't know if it really matters. Let me see. There might be a simple way. Int I 0 I less than points. Well, maybe I wouldn't want to use a for loop here. Well, actually, yeah, I think I will, but we'll actually kind of cheat. This will be P. less than number of points in a big row. Okay, and so I have the near and far, and then the mid. Okay, the thing is that this is just for one. Like ribbon, isn't it? This code is a bit complicated, but I think a lot of this is in common. Okay, I see. This is what I need right here. So I want to calculate this, I think. Yeah, because then everything will just be a combination of these 4 points. And the colors are the blendings. But I don't really have to have these values myself. Oh, I do use get terrain index. Okay, all it did was just if neighbor was null, it just did a backup. I should have known if I needed to check if everything was not used, that if something is a comment, of course it wouldn't show up. Okay, I will need to get the terrain. So I can't actually use these lerp values yet, that will come later. Alright, so I need to remake that get terrain index. I shouldn't have deleted it. Private int get terrain index, and we'll just take the block prototype and then block prototype backup or fallback. And so if this is null, then we'll use the fallback prototype, which is guaranteed not to be null. Index, yeah. And if we were using the new version of Unity, which has the new version of C#, we could use the fancy, what they call null coalescence operator for this, where if prototype is null, it just skips over a certain thing. I think it's like you'd return a proto. Can I already use it actually? Fallback dot texture index. Okay, I can already do that. Oh yeah, the thing that's not supported is that, which would mean that if this was null, then it just wouldn't call this next value. Alright, and so the near and far values are just 0 and 1, so I don't really need to have a separate thing for that. And then the near corners, we don't have to lerp between them, so this would just be the same as passing 0, which is just that. And then the far corner is the neighbor's cell. And then we don't need this midpoint because we're going to be calculating that when we go through the loop. So, okay, so float, big row lerp is Okay, so I do kind of need to know what row I'm on. I can't just go through the points. I need to know the number of big rows, which is database, metrics, x subdivisions plus 2, because there's always one at both sides of the margin. Okay, so we'll use R for this. And the lerp is simply, so for when R equals 0, when R equals 0, we want big row lerp to be 0, and when R equals num big rows minus 1, we want it to be 1. So could just use mathf inverse lerp. Which is, I don't think I've used it much here, but it basically just returns the lerp value that R sits at between these two numbers. So it's exactly what we want. Yeah, because if, for example, this was 0 and this was 2 and R was 1, then it would return 1/2, which, yeah, is correct. Okay, so now here, I guess I should keep a count of like the start point index. And instead of using P, well, I will need to keep that separate. So at this point we would just, oops, thought I copied this. We would increment that by a number of points in the big row. Oh, trying to do equals there. Oh, get train index actually takes a blueprint cell instead of the prototype. Okay, well the cells will never be null, so I can still use this null coalescing operator. Alright, so now I need to know the point lerp on the big row. So float point lerp. I guess we can use inverse lerp again, which would be from 0 to num points in big row minus 1. Don't really have to do the p because I think it would automatically, I don't have to do the float, I think it automatically gets converted to a float there. Okay, so now I have all the information I need. I guess I can calculate vector 3. So I guess big row anchor is, so I need to lerp between both of the near corner A. Well, is this gonna work actually? Oh yeah, I can't, it'll be a little bit, this gives us a point and then I need to find the axis between A and B. I don't know, is that a good idea? Now that I think about it, because I think the margin is parallel, but it might not be guaranteed to be. Because what I was gonna do is the first point, or to find this very first point, we would I think I actually tried this one time and it didn't work correctly, so I think it's probably a bad idea. Yeah, because I was gonna just lerp between here to find this point, for instance, and then we would find this direction and then just multiply it and add that value to for each offset or on this direction. But that that assumes that everything is parallel, and due to deformities, it won't be. Okay, so how would I actually do that? I guess that what I need to do is lerp between A and B to find these 2 points, and then lerp between them to find this point. So I just need to vector 3, lerp, near corner. Oh, I can't even do this yet. Okay, so I guess this would be the near anchor. Well, I could do it, I don't know. Let me think here. Right now, in order to find, I'm just using the corner points. But what I actually have to do is find the point, because I want these margin points to match up with the hexagon points, and they're not just a straight, it's not just a straight line. How did I do that before? Because I didn't share points. Oh, well actually, yeah, because I assume it's a straight line, and then it gets perturbed in the same way based on this flat position. So I think I'm still safe here. Okay, yeah, this should be okay. So right now I'm trying to find the clockwise and counterclockwise anchors, and then I'll lerp between them here because this is going along the face or the edge of the hexagon. So clockwise point is oh no, it's just a normal lerp between near corner A and far corner A. Maybe I'll just use A instead of clockwise. Oh, what's it not like? Oh, again, I use math F instead of vector 3. Oh, I wanted to change the B there. Okay, so here, once I find this, the final position is just a lerp between point A and point B. So flat is vector 3 lerp. And so from there I just call points, start point index plus R plus P actually, equals make new point. So it's my cell. If the neighbor cell is null, or no, the prototype could be null, so that's why I've got to call get. Or how did I do this actually? Because Oh, I did just give it... Oh yeah, if the neighbor's self-service proto is null, we actually take care of that in this make new point. I forgot. Okay, this should be... Okay, not gotta give it the position, and then the blend is... Wait, I'm confused. Okay, I actually get the lerp first, which... Okay, so this is actually this big row lerp because I'm going from near to far. And then the blend values... let's put this in this row actually. Is new vector 3, 1, 0, 0, and 0, 1, 0. Because it's between the red and green terrains. Okay, so that's taken care of, and then we add the point index, and so if R is less than num big rows minus 1, then that means we have to do a small row. So float small row lerp is mathf inverse lerp. Okay, and this one's a little more complicated because we have this little offset here. And I guess that's half the distance between two. How did I figure that out before? I didn't comment this out very well, so I'm not sure which ones I'm making. Okay, this one starts on the near and then goes to the midpoint. So all I do is offset t by 1/2. I guess that makes sense. So here, what I would do is just offset this p to 1/2. And the big row lerp here. I'd offset r by 1/2, I think. Okay, and then I need to calculate these again, and I think I'll just overwrite them. And so P is num points in big row, minus 1. Let's be a little better here. So num points in small row is just that. Although I don't think I wanted to offset it here. These are functionally equivalent, but because I was going to say num points in big row minus 1, but that's the same as number of points in small row, so I don't know what is clearer. So the P, the largest value of P is num points in small row minus 1, so this never quite reaches that. And if I add half to it, I think that will give us the right point. So then we just slurp that and then we make a new point. These are the same, so should I separate it out, or would that be a bit too many arguments to pass? I think it is a lot because I have to pass flat and the start index, my cell, neighboring cell, and the lerp. Okay. Well, I mean, it's not that complicated, so I think I'll just leave it. Okay, so at this point it should be done. It'd be nice if we could set up some triangles to see what's going on. So maybe I'll just do the first row of triangles and see if that's right. So it would just be these. I think this is like really old because I think it just has the margin triangle just be one big triangle. So go ahead and delete that. Okay, so the triangles, I guess I'll have it like make one margin. I think I'll call it a ribbon because we'll do this section first and then this section. So int num triangle ribbons is database metrics margin rec subdivisions plus 1 because if this is 0 then there's one ribbon. And for int r equals 0, r less than triangle ribbons, then we will do call this function. I think I'll rename it. Create margin try. Okay, this is gonna be a little confusing, but rect try ribbons. Okay, so what I need here, if I look up at the hexagons, I had to figure out the number of points and everything. It's a little bit more complicated. I guess I will need at least the number of points in a big row, which I can just use that. And I'm just going to make the first one, which has 2 points on the near edge. 2 points on the near edge. One good thing about these margins is I'm not going to have to wrap around because they never, like the points aren't actually shared between extra margins. So that makes it simple. So, but the number of triangles here is 1 minus the number of points. So, do I actually want the points or triangles? I'll leave it like that. Int t equals 0, t less than number of points in big row minus 1. And so I need the starting point index. So I guess I'll say ribbon start index, and that is, we already know the number of points in a ribbon is just number of points in a big row times 2 plus the number of points in a small row. So I guess that's times 3 minus 1, isn't it? Yeah, it's the same. Yeah, so 2 big rows and 1 small row. Although, is that actually the start index? Because this other one actually starts at 7. Yeah, because these are shared points between both ribbons. So it's actually times 2 minus 1. So yeah. 1 big row and 1 small row. Yeah, and I have to multiply this whole thing times r. So let's see. Theoretically, R times ribbon, not R. If there was a third row, then it would start at 14. Yeah, so that's right. And that's just 7 times 2, yeah. Okay, so just add triangle. Points. Oh, I need to pass the point array. Ribbon, start index, just to make things symmetrical. Add +0. Or not symmetric, consistent. And then this one is ribbon, start index, plus number of points in the big row, which is 4, which would be that one. I guess I need to add t to all these, don't I? So plus t, because we offset it by that. And then the last one is t plus 1. And this won't go out of bounds because we end it before, well, when num points a big row -1, so we're good. And then what else do I have to pass? The terrain. Oh, actually had that here, but I need it here. I don't have the neighbor cell, so I guess I'll get that. Do I? Oh, I do use those. Okay, that felt much easier than the hexagon face. Okay, I need to pass the points. Let's see if these triangles turn out okay. Oh right, rect points. It's giving me a lot of warnings that I already fixed. Small row lerp is assigned. Okay, well I need to fix that, I think. Got an out of range error here. First off, this should be used there. And here as well. Okay, and where was the out of bounds? It was right here, so start point index plus p. I would guess probably that the rect points is out of bounds. Okay, that's set to 0 already. Let's debug the total points, and I'll test if that is wrong first. Okay, so 8. Is that how many? There's no, it should be 7. Oh no, it should be 10. Or 11, yeah, because it's 8 plus 3. So, what's going on there? Points in big row is number of points at hex edge. Actually, how many? So I only have 1 subdivision, so that means that there would be 3. Okay, so that would be 3 times 2, 6 times 2 times 1, so 6 plus 2, so that's 8. That works out right, and let's see. So basically, if we assume that the ribbon ends here, then that'd be 1, 2, 3, 4, 5, 6. So it should be 7, 8. Oh, well, that is right, actually. Right, it was 8? Yeah, so that is correct. It's actually some other code here that's wrong. Did I comment out that other debugger, or did I just delete it? I think I just deleted it, which was a bit silly. String, format, point. I think I really just need the position and the index. Okay, so 0, 1, 2, and then it switches. Yeah, that's right, because there's 3 points on this row, and then it switches to the small row. Then there should be 2 of those. 0, 1, 2. Oh, it skips. Do I add to that twice? So the number of points in the big row is 3. Oh, no, this piece starts at 0. Oh, I skip it because I don't have this debug line in the small row. Okay, that was my fault. So it doesn't actually skip. Let's try it one more time. Okay, so yeah, the big row, and then it goes to the small row. Then it does another big row, and that should be it, but it... Okay, I see. It's trying to do another small row, but I thought that's what this fixed. Because if R is less than the number of big rows minus 1, then it shouldn't go through here. Okay, so this, right here, we have 1 hex subdivision, so the number of big rows... Oh, this is wrong, actually. This should be margin subdivisions. Okay. The number of big rows is equal to the number of margin subdivisions plus 2. Alright, let's check that. No errors. Okay, yeah, the reason that it takes so long to load is because, for some reason, as I've said before, doing debug logs is extremely slow, and that's the reason why it's taking a long time to load. Not because the actual algorithm is slow. But it actually, I think everything is good. It looks fine. I don't see any weirdness. Okay, let's do some other triangles. I wanted to finish this today, but I don't think I'll be able to. Actually, I wanted to finish the entire margin, but... So 2 points on... Okay. 1 on mid. And then this would be 2 points on mid. 1 on near. this one is 2 points on mid, 1 on far, and 2 points on far, 1 on mid. Okay, so this one is actually -2. And we start... I gotta make sure I do the winding right. Oh, and I have these corner triangles. Well, we'll do those later. I forgot that's a little different. Yeah, so the winding is gotta go clockwise, so we actually might start there and go like that. So this would be ribbon start index plus T plus 1. Because at 0 we actually want 0.1 right there. And then the next one we want number of points in the big row plus T because we want the first on the small row. And for the second one we just add 1 to that. Okay, and then 2 points on the mid edge and 1 on the far. To go clockwise, we could go like that. Or I could start on the mid, but I think it's easier to start on the... Well, I guess it doesn't really matter that much. So the far edge is start index plus number of points in big row times 2 minus 1. Yeah. Okay, let's change this to near start index, and I'll just make a bunch of little variables here. Mid start index is near start index plus number of points in the big row, and far start index is near start index plus number of points in big row times 2 minus 1. Okay, so now I can convert that. And that does make it explicit which row we're trying to access here. Okay, so far start index plus T, and then mid start index T plus 1, and then we'll, since we have to go clockwise, we'll go back to the mid start index. Oh, this is supposed to be 2 points on the mid. Oh, that's right. So far, that is how it would work. And this is 2 on the far edge, so... Oops. And then plus 1, and then mid plus T, because at 0 we want the midpoint number 0, because we're going like that basically. Actually, okay, here it should be plus 1, because at 0 we want the far point number 1, which is this one. Okay, and let's see. For the ones with 2 points on the mid edge, it's -2, and then for ones with 2 on a near or far edge, it's just -1. So I think that's it. We should have an almost complete ribbon. Oh, I need to get rid of those debug logs because that makes the startup time really bad. Yeah, and it looks pretty good. Let's see. Yeah, I don't see anything weird. So we're missing this triangle here, and then the actual tri-point triangle, which we're going to do later. Because it has to blend between 3. Which, speaking of blending, it all looks... blending between terrains looks fine. Let's check the normals real quick. Make sure nothing crazy is going on. I it uses the same code as all the others, so it should be fine. But on slopes, that's a little weird. On slopes, it points straight up. It actually should point sideways. So what is going on there? Oh, you know what? I think it's because the slopes don't take changes in elevation into account, and they only care about the changes in the height map. So what I need to do is provide like a normal surface that, or I guess a tangent direction. Okay, yeah, we'll need to fix that. Let me write. We don't have time to get into that today. So fix normals on slopes. And then we gotta do the edge triangles on margin rectangles, and then we have to do the tri-point triangles. I guess I should call it tri-blend. That makes it a bit more obvious. Okay, and then we'll be done. I'd wanted to finish this today, but with that crash and some of this math just always takes longer than you think, so it's alright. I guess we'll finish up on Monday and then start something else. Probably, like I said, working on terrain. I also am like I keep on saying, I'm super excited for the new Unity version, so I really want to start getting the code ready for the entity component system. So I might, I don't know. I mean, it's not going to be the most exciting because we're going to be just rewriting bits and pieces of code everywhere in the project, but so I might try and take it in small steps, but we'll see. Yeah, but I really should try to focus on making the game playable. Like, we gotta get a better camera. I did actually finish that. And that. Alright, but anyway, I think I better stop because I'm getting pretty hungry. But thanks everybody for coming by and watching. I hope you've all had a great morning so far and that you're gonna have a great weekend. And I'll be back Monday at noon Eastern at the latest. I keep on wanting to do weekend streams, but I'm actually really busy this weekend, so I don't know if I'll be able to someday. But if you want to be notified when I go live next, feel free to follow me here on Twitch, or you can check out my Twitter. I also have a YouTube channel where I post all videos, or all VODs if you'd like to catch up on anything that you might have missed. And finally, I have a Discord channel that you can chat with me and other viewers throughout the day. We'd love to have you there. I'll put links in chat, and you can also check out video description if you're interested. And I think that's about it. So again, hope you all have a great day, and I'll see you Monday. Bye bye.